Hello students, Namaskar, welcome in online learning process. I am Mrs. Rekha Sagar from Bitco Junior College. Today from the topic of electrostatics, we will discuss about electric potential energy of a system of charges without external electric field and within external electric field. Also, electric potential energy of a dipole in external electric field. Now let us discuss about potential energy of system of 4-point charges. In the last lecture, we already discussed about potential energy due to system of these 3 charges, and there the formula is like this, yes or no. Now by analogy, you can write down formula for potential energy of a system of 4 charges, but still we will discuss about this. So complete this diagram. We have to bring this fourth charge Q4, so we have to do work against field due to Q1, field due to Q2 and field due to Q3. So for this purpose, let us complete this diagram. Show all these distances and you know significance of all. So write down formula for work done to bring this Q4 charge against field due to Q1, against field due to Q2 and against field due to Q3. It is very simple. See, I have written here and in the last lecture we already discussed. So write down yourself. चला करा लिहा तुम्ही, आपण हे बघितले ऑलरेडी सगळं लिहिलं. मग आता व्हॅल्यू सबस्टिट्यूट करायच्या. सबस्टिट्यूट व्हॅल्यू ऑफ पोटेन्शियल ॲट डी ड्यू टू Q1 into Q4, potential at D due to Q2 into Q4 and similarly about Q3. मग आता 1/4πε0 कॉमन घ्या. बघा ब्रॅकेटमध्ये काय राहिलं. ठीक आहे. and this is the formula for potential energy when there are 4-point charges. By analogy also you will write, or like this also you can derive. Electric potential energy of a system of n-point charges. आतापर्यंत आपण 4 बघितलेले आहेत. To assemble charges Q1 to Q4 work is done and that work कसं केलं होतं बघा बरं, आपण आठवतं का? To assemble this charge Q1 from infinity to this point A, no any work is required because there is no any opposition. मग आता to assemble charge Q2 from infinity to this point B, आपल्याला काय करावं लागेल? We have to do work against electrostatic force of Q1 and that work done. हा फॉर्म्युला आपण बघितलेला आहे, पाठ व्हायलाच पाहिजे. 1/4πε0 Q1 Q2 अपॉन R12. 1-2 आहे, 1च्या अगेन्स्ट करायचं आहे 2ला, म्हणून 1-2 आणि इथे पण 1-2 असं लक्षात ठेवलं तरी चालेल. मग आता नंतर काय करायचं बघा आपल्याला. We have to bring this charge Q3 from infinity to this particular point C. किती वर्क करावं लागेल आपल्याला? वर्क अगेन्स्ट इलेक्ट्रोस्टॅटिक फोर्स ऑफ बोथ Q1 आणि Q2 दोघांच्या अगेन्स्ट करावं लागेल. मग लिहा फॉर्म्युला. ॲनालॉजीने लिहिता येतोय आता आपल्याला आणि आपण हे सगळं डिटेलमध्ये बघितलेलं आहे. ठीक आहे. त्यामुळे हा फॉर्म्युला लिहिला. झाला लिहून तुमचा, पण फास्ट करायचं आहे आता. आता पुढे काय करायचं आहे आपल्याला? Q4 पण आणायचं आहे. कुठून? फ्रॉम इन्फिनिटी टू दिस पर्टिक्युलर पॉईंट डी. किती याच्या अगेन्स्ट फोर्स वर्क करावं लागेल? फोर्स अगेन्स्ट Q1, Q2 अँड Q3 आणि तो आत्ताच आपण लिहिला. बघा बरं हा झाला की नाही. मग या पद्धतीने जेव्हा आपल्याला n नंबर ऑफ चार्जेस असेंबल करायचे त्यावेळेस पोटेन्शियल एनर्जी आपल्याला काय करावी लागेल? समेशनच्या भाषेत लिहावी लागेल. म्हणजे ही झाली ती पोटेन्शियल एनर्जी व्हेन वी हॅव टू असेंबल n नंबर ऑफ पॉइंट चार्जेस. लक्षात आलं? मला वाटतं आता आलं असावं. Now see potential energy due to 2 charges or 3 charges or 4 charges or n charges at a glance. Now see here, we already derived this formula. This is the potential energy due to only 2 charges Q1 and Q2. Work done to bring this Q2 charge from infinity and to locate it at point B. Work must be done against this field Q1. Clear? Now second, energy stored or work done to bring 3 charges. Now here how many times we did this? I think 2 or 3 times. So this is the work done, which is nothing but energy stored. And similarly, when 4 charges are there, so here see what are the difference between these derivations when 2 charges are there, when 3 charges are there, and when 4 charges are there. I think you got this idea. Electric potential energy of a single charge but in external electric field. आतापर्यंत आपण बघितलंय 1, 2, 3, 4 इवन n चार्जेस असेंबल केलेत, पण तिथे एक्सटर्नल इलेक्ट्रिक फील्ड नव्हतं. आता मात्र आपल्याला सिंगल चार्ज एक्सटर्नल फील्डमध्ये असेंबल करायचं आहे. त्याच्यासाठी आपण इमॅजिन करणार external electric field is produced by means of some agent which is in this direction, and in this electric field at point B, which is at a distance r from O, we have to bring charge Q from infinity. लक्षात आलं? मग हे करण्यासाठी आपल्याला काय इमॅजिन करायचं आहे बघा. This field E which is produced, it is not produced by the charge or charges which we are bringing or assembling. आपण जे चार्जेस आणतोय किंवा असेंबल करतोय त्यांच्यामुळे हे ई तयार झालेलं नाही. याचा सोर्स आपल्याला माहिती असेल किंवा नसेलही, पण अशा एक्सटर्नल फील्डमध्ये आपण हा चार्ज आणणार आहोत. लक्षात आलं? मग आता वर्क डनचं फॉर्म्युला अगदी सोपा आहे, बघितलंय आपण. वर्क डन इन ब्रिंगिंग अ चार्ज क्यू फ्रॉम इन्फिनिटी टू द पॉइंट बी is given by this formula. म्हणजे कोणता? प्रोडक्ट ऑफ चार्ज अँड इलेक्ट्रिक पोटेन्शियल. अगदी सिंपल आहे. झालं. दिस इज द वर्क डन ऑर एनर्जी. Gravitational potential energy of system of 2-point charges in an external field. In this case, what we have to do? Work done in bringing charge Q1 from infinity to point A in external field. This means, see, this is point Q1, we have to assemble at A, which is at a distance R1 from O in this external electric field. What we have to do? Work must be done, and this work is nothing but, we can write down formula for work, W1, which is nothing but Q into V, that is Q1 into V, and R1 indicates the particular position. Clear झालं? Now, we have to bring another charge Q2 from infinity to the point B. Means here we have to bring this charge Q2 from infinity to this particular point B, which is at a distance R1, R2. So what is formula for that? Tell me. We have to do work against field due to Q1 and work against this external field. Yes or no? 2 times we have to do this work. So it is written here. Write down work against external field and work against field due to Q1. आता तुम्हाला यायलाच पाहिजे. आपण खूप वेळा घेतलेत हे फॉर्म्युले. मला वाटतं तोंड पाठ झाले असतील. लिहिलं बघा मी. हे तुम्ही लिहिलं पाहिजे. तुम्हाला हे आलंच पाहिजे. आलं? ओके. मग आता total work done in assembling these two charges is sum of W1 and W2. So substitute from equation number 1 and 2. So this is the required formula for work done in assembling 2-point charges in external electric field. Now see here, clear difference between potential energy of 2-point charges in external field, but same 2-point charges without external field. Now see here in this diagram, this E indicates external field is there, and in this electric field we have to locate charge Q1 and Q2. While in this case, though we are locating here charge Q1 and Q2 at A and B, no any external field is present. Now so to locate charge Q1 and Q2, the simple work done is given by this formula, and we discussed about this. But when same 2-point charges are in external electric field, then what we have to do? Work against external field to locate charge Q1. This is that work. Then work done to bring charge Q2, we have to do 2 times work, that is work against external field and work done against field due to Q1. So this is the formula for total work done. See here, work done to bring Q1 against external field, work done to bring Q2 against external field, and work done against field due to Q1. So see clear difference between work done or energy stored in these two cases. Now you must not get confused. When electric field is there, what is potential energy, and when electric field is not there, of course external, what is the electric potential energy. Electric potential energy of a dipole in external electric field. Now see here, this is the external electric field, direction is as shown. In this electric field, the dipole, that is minus q and plus q, these two charges are separated by this distance 2L, and this system forms a dipole, and this dipole is kept in this electric field in such a way that axis of this dipole makes angle theta with the direction of E. Now here on plus q, F force is acting, which is in this direction, whose magnitude is q into E. On minus q charge, q into E is the force acting, but which is in opposite direction, means in this direction. These two forces, this force and this force, which are same in magnitude and opposite in direction, forms a couple. Now here P is the electric dipole moment. The direction is as shown from negative to positive. Now as per this diagram, we have to write down description. So write down this description, and in this description the things are written here. Now we know that the magnitude of torque is given by one formula, and that formula is nothing but product of magnitude of any one force and arm of the couple or moment arm. So magnitude of any one force is Q into E, and this formula is by basic definition of electric intensity, which is force per unit charge. By cross multiplication, you can write down formula for this F as Q into E into arm of the couple or moment arm, which is nothing but 2L sine theta. This 2L sine theta is nothing but perpendicular distance between what? Line of action of force. This is the line of action of first force, this is the line of action of second force, and this distance, perpendicular distance between line of action of these two forces is 2L sine theta. Why this is 2L sine theta? Since this angle is theta, this hypotenuse 2L, so this side ultimately is 2L sine theta by geometry. That's why here this moment arm is 2L sine theta. Next to this, we have to rearrange it and simplify it. After rearranging this, what we will get here? Yes, tell me what this product is. Q into 2L. I have arranged it in such a way that Q into 2L first and then E sine theta, and this Q into 2L is nothing but product of any magnitude of any one charge and distance between two charges. This is called as electric dipole moment, which is denoted by this P. So this P is nothing but Q into 2L. So for this the P is replaced. Now here this P into E sine theta, it is nothing but the torque, and due to this electric dipole is rotating. Now in order to neutralize, external torque is applied. So when external torque is applied, it rotates that dipole in the plane of paper from theta 0 to theta. So during this, the work done by external torque is stored in the form of energy, and that energy is potential energy. So let us find out this work done, and it is nothing but integration from theta 0 to theta torque, external torque into d theta. We know in linear motion work is force into displacement. In angular motion work is nothing but torque into angular displacement. That's why this formula. Now let us substitute value of this torque, that is P is sine theta. I have substituted here. Now find out integration of this. What is constant here? P E is constant. So which is next step? See here, P E is constant, and integration of sine theta with d theta is minus cos theta. Now let us substitute these limits. First we will substitute upper limit, that is minus cos of theta. then lower limit minus cos of theta 0. Now next to this minus and this minus, it will become plus. So simplify it and see, this is the next step. You got this step or not? Next to this, now let us rearrange. Write down this plus first and then minus. So this is the next step. And this is what? This is the work done which is stored as a potential energy. So we can write down this potential energy is Pe cos of theta minus cos of theta 0. This is the final formula for energy of the dipole in external electric field. If the dipole is perpendicular to E, means direction of the E, electric intensity, and direction of axis of dipole, both are perpendicular to one another. So this is that figure. This is the direction of E. This is the axis of dipole, and angle between these two is 90. That is, these two are perpendicular to one another. Now what it indicates? This theta 0 is equal to 90. Now let us substitute this value of theta 0, 90 in the equation of energy and write down next step. So this is the next step. In this case, you have to substitute theta 0 as 90, and we know this cos 90 is 0. So this is the next step. So finally it is minus Pe cos theta, and we know as per definition of scalar product or dot product, this Pe cos theta is nothing but vector P dot vector E. That's why this is the step. Second case, when axis of dipole is parallel to the direction of E. This is that case. This is the axis of dipole and this is the direction of E. Both are parallel to one another. So what about this theta 0? This theta 0 is 0. Once again in the formula, substitute this theta 0 as 0. And we know this cos 0 is 1. So this is our required equation. Thanks for watching this. Thank you very much. Read these lines. कुछ भी नामुमकिन नहीं है अगर आप कोशिश करेंगे. Wait for next video. Thanks.